Okay, so we were continue talking about square roots and how to solve the question of square roots because that's actually one of like the harder topics of the course that what we'll do like the last kind of topic for this course, which is like equations involving fractions. So those two are pretty complicated things. So it is better to kind of be careful and go slowly with that. So like when we were doing the examples, when was it, like Thursday, I didn't really have like a good example where it kind of showed why it is important to verify the solutions that you found when you have like an equation involving square roots. So I'm going to start doing that and then kind of give you other examples with equations and square roots. So let's continue on this topic. So I didn't realize that like one of the problems I had given you for you to work during class uh, illustrates it pretty nicely. So I'll kind of do it here just to kind of like point some important points. So let's try to solve. So let's try to work on that equation, which again I kind of gave you as a problem last week, but I didn't do it on the board, and it's useful to kind of discuss what's going on here. So what I mentioned last time when is that whenever you have an equation involving the square root, what you want to do is kind of isolate the square root. And so you basically solve for the square root. So in this case, like everything is on like all the expressions are on one side of the equation. So you kind of want to isolate the equation for this term. So to do that, you just like add x and subtract two on both sides of the equation. I'll do that quickly. But I'll add first. I'll add x first. So here goes okay. So when you do that, you get that. And then I'll subtract two on both sides. Okay, and so what does that give you? It gives you root of x plus 4 equals what? Okay, so now the equation has been solved for the square root. That still doesn't mean that that is the end of the story because we still want the value for x, but like the first step is always like solving for the square root. After this one, I'll do an example where there are kind of two separate terms involving squares, which is a little bit more tricky. So that you'll see what needs to happen in that case. But for now, like if there's only one term involving a square root, what you want to do is isolate it. Okay. Okay, so after you do that, like the reason for isolating the square root is that you want to square both sides of the equation to kind of get rid of it. And so that works the best if you have like the square root on its own. So now I square both sides. Let me put that in words like here, square both sides. So meaning that I'm going to square. Yeah.
Theoretically, you could, even though you don't recommend it, you could technically square right at the start.
Yes, you could, but the thing, The reason why I do avoid that is that then, like, say this square here, you have to square something that has like one, two, three terms, right? And the problem is like when you square, like the square is not like kind of like the square of each individual term. There are a bunch of like mixed terms, which is sometimes how you call them. So it does become a lot messier if you do that. And that's why it's not kind of like the best idea. But yeah, like theoretically it's possible, but it doesn't make your life easier. Like the majority of the cases, like kind of like works against you. Because the reason is that, say for example, to work with something like this, what I'm going to use, like I'm going to use this formula for a minus b squared, which I have written before to deal with this term, and say there's like a similar formula for something that involves three things. But it is a lot longer than just this. Like there are a lot of more, like a lot more things involved. So yeah, like it can be done, but it won't make it. Yeah, it will work against you basically. Um, but no, it's a good question. But yeah, like when you're trying to kind of minimize, like when you, because if you're going to square, you want to minimize kind of like a lot of terms of one side of the equation, because like that's the thing with squaring. It does create a lot of extra stuff. So that's the main issue. So I'm going to use this identity. Okay. On the second one, like the first one is basically okay, because that's essentially the idea of a square root. Like it is defined so that when it sees a square, it kind of just goes away. That's the point of a square root. So the square root squared like just gives you x plus 4. Okay. So you have x plus 4 on the left hand side. But for this one, you do need like for this one you do need to use that formula. So here, like A is like X and 2 is B. Okay, so if you do that, you have to square the first term. Okay, then minus 2 times the product of the terms, so like these, and then you add the square of the second terms. Is that okay? And then what is happening here? Uh, Now after this, like it's like a little bit of simplification. So if you x squared, so these two with these two gives you 4, so you get minus 4x, and then 2 squared is also 4. Okay, and now like you get to like a more like regular equation that we have solved before, because it's like a quadratic equation. So to solve a quadratic equation, uh, there it is useful to have everything on one side of the equation. So like I'll just kind of like do the same thing, like I'll subtract x on both sides and also subtract 4. I'll do both steps like at the same time, because it's not too complicated. So I'll do this minus x minus 4. So minus x minus 4. Okay, so this will give you 0 on the left hand side. And then let's see, like there's only one thing with x squared, and then this minus 4x with this minus x becomes minus 5x. And then the 4 with the 4 goes away. So like I'll just put plus 0 to specify that that's what's happening here. Although like obviously like plus 0 you don't need to write, but just to kind of emphasize that these 4 when like disappear with this negative 4. Okay. Um, and then, but let me just like this. And you want to solve for x. So in this case, like the easiest thing, it's actually not such a bad quadratic equation. You can factor out an x. That's the easiest thing to do here. So if you factor out an x, because there's an x common to both terms, get x minus 5. Okay. And then, before continuing, so far, some good questions about this. And then you get to this other important point, which is like when you have the product of the numbers being 0, that means that one of the numbers has to be 0. That's the only way for two numbers multiplying to give you 0. One must be 0. So the options that you get from this case is that either x is 0, so either x is 0, or x minus 5 is 0. Okay, this one is already kind of done for you, like there's nothing else to say, but like if x minus 5 equals 0, that means that x has to be 5. Okay. So the two options that we get are that x could be 0 or x could be 5. That makes sense. And now, this is what I wanted to emphasize last time, but I didn't have like a good example. Now, what you'll see is that one of these two do not solve the very first equation I wrote on the board. So that will illustrate like the point that you have to double check the equation. Like, I mean, you must double check the solution after you're done. Like what's happening, like just to explain it, because like maybe like I don't want to raise the original equation because I was what I'm going to check now, but like maybe just to put it here on the like on the box to kind of explain what's going on. Like the thing is like you can have different equations that when you square them give you the same equation. So like just to make like a very silly example, like you could have like an equation like x equals negative x equals 1, right? If you square this, right? If you square this equation, you would get x squared equals 1, right? But then you could have like a different equation which like x equals negative 1, right? And if you square this, right, you would get that same equation, like which is x squared equals 1. So my point is that squaring is like a very useful technique, but the problem that it has is that different equations can have the same square. And so when you solve the squared version, you have to make sure that you're actually solving the equation that you care about. Like so, like kind of squaring gives you that issue. So like it's not super important to understand this detail, but like what it is important to understand is that whatever you find, you must double check against the original equation. But it basically is kind of coming from this fact that, different things can have the same square. That's one way to say it. So what I'm going to do is to check these two potential solutions, like because at the moment I'm not sure which one works. So I want to check the potential candidates or like the candidates on the original equation. So you must check the potential solutions. Okay. So let me do it for both. Like let's check first like x equals 0. Let's check x equals 0. That's actually the one that doesn't work, I believe. So if you put x equals 0 into the equation, you get 0 plus 4 plus 2 minus 0 equals 0. And so what is that saying? This is saying like square root of 4 plus 2 equals 0, right? So you get 2 plus 2 equals 0. And so you're getting that 4 equals 0, which is completely false, right? So this is false. So x equals 0 does not work on the original equation. Okay. That makes sense so far, so good. And then you do exactly the same for the second option. Now let's check x equals 5. And so you get square root of 5 plus 4. 2 minus 5 equals 0. Okay. And so this gives you square root of 9. 2 minus 5. Okay, that is you can, like that's negative 3D, like actually. So let me put it plus minus 0. So you get three, like the plus minus is just minus, so 3 - 3 equals 0. And then just saying that 0 = 0, which is true. But this is true. So, what's- so in general, for like any question involving square roots, it is important to double check this. It could be that sometimes you're lucky and both work, so if you have not checked, there's no harm was done. But sometimes you can have like this situation where actually one is a big solution, and you could like something less likely because like at least most in the examples I'll give you, I'm more or less interested in there being a solution. But you could really be super unlucky and there was no solution whatsoever. And so there's no reason kind of like to freak out if none works. But I would double check that just to make sure like you didn't make like any arithmetic mistakes. At least like would, for most of the problems I would give you like, there will always be at least one solution. But yeah, like, there's no rule like as to how many have to work or anything of that sort. Just whatever works, works, and whatever doesn't work, doesn't work. So it's like there's no, you shouldn't kind of create expectations about what's supposed to happen. That makes sense. Okay, now I'm going to do a slightly harder example because it will involve two square roots, two separate square root terms. I'll give you a second just to copy this. Maybe I'll raise, I'll raise this part to start working. It's a very similar problem, but now two things involve square root. Um, Wouldn't be great square both sides. I do have to square both sides, but what's a little bit better in this case is to have one square root on one side of the equation and the other on the other. Like, kind of like.
This still does the same thing.
It does still do the same thing, but kind of like that's what I was going to do first. Like, what happens if you just square this directly? It works, but it kind of does make the like it does make it a little bit more complicated versus like just having square, like, before squaring, like kind of like moving one of these to the other side. So I'll do it two ways, like just kind of to like illustrate the difference. So like, you know, like option one is just to square like the equation as it is because like everything that has square roots is on one side of the equation. So option one. And this will be longer, but you'll like it's kind of like you don't really see it until you kind of like just do it and see what happens. So this will be a bit longer. So it's not the one that I'm going to recommend, right? Like I'm just kind of writing first my non-recommended version, but just to kind of show you what's happening, what's going to happen, which is going to be just square the equation as it is. So square the equation without doing anything to it. Square the equation as it is. But again, this will be longer, so not the one that I will use in general, but like I still useful to see what's going to happen. So by that, I'm going to, oops, again, like the thing is that when you square, that affects the entire, like everything on on each side of the equation. So like the squaring is not, it doesn't refer to squaring each individual term. You have to square like the entire expression basically. Okay. Okay, and so what's going to happen here? Uh, so what I'm going to do, okay, the right hand side is not too bad, it's 20, it's just going to be 25, that's fine. To square the left hand side, I have to use a plus b squared, the formula for a plus b squared. So what is the formula for a plus b squared? Actually, let me put it like right below where I want to use that. So a plus b squared is going to be a squared plus 2ab plus b squared, okay? Uh, because it is a square of a sum, that's the thing, which is what will make it longer. So then, like, let me write everything like carefully. Let me actually erase here to have more space. Right. So you want to square the first term. You want to do root of x minus 5 squared plus 2 times the product. So 2 times this times this. So 2 times plus root of x squared. And that's supposed to be 5 squared, which is 25. So let me just erase it. So that is what the left-hand side is. And of course, it can be simplified still, but like, just kind of showing you what's happening here. Does that make sense? So what is the square root of x minus 5? This is just x minus 5. Um, this you can leave as it is, that's fine. Well, if like if you prefer like when you have like the product of two square roots, like that's the square root of the product, so I'll put it like x minus 5 times x. Okay, that can be done. And then the other one is uh, this one. Yeah. That's just like the root of a times root of b is the same as root of a times b. Okay. Yeah. Let me put like in boxes like property that I'm using. So just so that it only looks as if you had like a single square root. It kind of looks a bit nicer. And then the other one is just x. So that equals 25. And okay, so what are you getting here? You get there's a 2x um, minus 5 plus 2 root of x minus 5 times x equals 25. Okay, and now it doesn't look as, it looks similar to kind of like the previous equations where like they're solving like a single thing with a square root. So you can solve for the single term with the square root. So to solve for the single term, what I'll kind of subtract is 2x and add 5 to both sides of the equation. So I'll do 2x minus 5 plus 2 root of x minus 5 times x. So I'll add, what I'm going to subtract 2x and I'll add 5 to both sides of the equation. So like 2x with this negative 2x becomes 0, this negative 5 with 5 becomes 0. So you end up getting 2 root of x minus 5 times x equals 30 minus 2x. Okay. And if you want, before squaring, you can multiply both sides by 1/2 just to get rid of the 2 of the in front of the square root. So do 1/2. Or divide by 2, like, both sides. That's not fair. And so this gives you what? It gives you, like there's nothing left here. And then this is like 30. Sorry, like this 1/2 affects every, like each term. So 30 over times 1/2 becomes 15, and minus 2x times 1/2 becomes minus x. So first, and then what do? You square both sides of the equation? Square both sides again, so square again. So again, this is the longer method. This is not the method I'm recommending, right? Like it's kind of good to see what's happening if you do it this way, because otherwise you don't really see the difference. But it's still good to kind of like, because it can be done, so there's nothing wrong with doing it to see what happens. Okay, and then this one, what is this? Like when you square this side, this gives you, like the square root goes away, like so you get x minus 5 times x. And for this one, you have to use like the identity of a minus b squared. Let me put it like here again, like I have used it before, but I'm going to use that a minus b squared is a squared minus 2ab plus b squared. Okay, uh, so you get 15 squared minus 2 times 15 times x plus x squared. Okay. Let me erase this here. Okay, and so you can multiply these as well. You get x squared minus 5x. Equals. What is 15 squared? It's like 225, I think. Right, well, I like that. 226. Yeah, so minus 30x plus x squared. Okay, we're almost there. So you subtract x squared on both sides, right? So because like those x squared was the same term every both terms. You get minus 5x equals 225 minus 30x. And then I'll add 30x to both sides of the equation. Minus 5x, 30x.
Wait, what did you do to the x to the second?
Oh, the thing is like x to the second was both on the left side. Correct, yeah, yeah. Okay, we're almost there. So you get 25x on this side equals 225. Okay. The x is 225 over 25. Which is actually 9. Okay, so x equals 9. And this does solve the original equation. This actually, like, let me put it in words because like it's important to notice. Like, otherwise, it would have been very frustrating to do all of this, and this like only solution doesn't end up solving it. It would be a little bit of a scam. But no, it does solve. It's like an easy check. And again, this was a bit longer than it needs to be, so now I'm going to kind of do it in a slightly shorter way. But you know, this is like how it would go if you kind of just like straight up square both sides of the equation. Okay. Um, okay, so what is the other way to do it? So let me rewrite the equation like second option, solve this. So what is the second way to solve the equation? So option two. This is like the equation. And the idea for like, which is shorter and recommended. So shorter and better. So the idea for like the second option is that before you square, you kind of like rearrange the terms so that you know the terms with square root appear on up different ends, so like on different sides of the equation. So the second option is that before squaring, you put the terms that have square root on different sides of the equation. Put the terms with square roots. Okay. So you still will have to square both sides. That's always needs to be done. But before squaring it, I'm just going kind of going to rearrange a little bit the terms because what will happen, you'll see in a moment, is that that simplifies a little bit the formula for like the square. When you square both sides, what you end up getting. So it does make your life slightly better. Um, so So here, like, so far what's happening is that both terms with square root are on the left side, so one needs to be moved to the right side. It's kind of up to you, which one do you move? You can move a simpler term if you prefer. So like, let's move root of x to the right side so that they appear on opposite ends. So I'll work, so for that, you have to subtract root of x on both sides. So you, like, I'll move move simpler square root to the other side. Let's see. So that will give me, what is that going to give me? It's going to give me root of x minus 5 equals 5 minus root of x. So that is the equation that I will work with instead. It is the same equation as this one, but now the advantage that this one has is like this square root is on the left side, and the other thing with the square root is on the right side. And now after you do the rearrangement, now you do square again. Okay, so I'll square one more, like I'll square this equation. So I'll square. And again, for this one, we do need the formula for a minus b squared. I'll put it here. Put it one more time. So there it is. Okay. So what's going on? The left hand side, the left hand side just becomes x minus 5. What happens to the right side? You square the first term, so you square 5, and the 5 squared minus 2 times the product, minus 2 times 5 times root of x. And then you square the okay. So let's simplify this a little bit. You get x minus 5 equals 25. 2 times 5 is 10, minus 10, root of x plus x. That makes sense. So I don't know if you can kind of see why is this kind of better to work with, because before when we had squared all of this directly, we had ended like, I'll erase it in a second. But if you remember if you just square this directly, you get you had like a term that looked like this, right? Which was a bit messy. There's nothing like as bad as that here, because you had like the square roots on the opposite ends of the equation, like on the opposite sides of the equation. So we're kind of like avoiding, like maybe I'll put it below here. What we're avoiding is kind of like a mixed term, which is kind of like a product of square roots. Like that's the advantage of like doing this. So like I'll make it as a remark here. So we're avoiding things like this avoids something like square root of x times square root of x minus 5, which is a bit like ugly to work with. So that there's nothing as bad as in here. Like the worst you are getting is like square root of x, which is not that bad, to be honest. So before solving this, we can like kind of fix, like improve a little bit how this equation looks like. I'll just copy paste it here before like doing some work to it. So let me just rewrite it. So you have x minus 5 equals 25 minus 10x root of x plus x. And then what do you see? Like I see that there's an x here and here, so I'll subtract x.
Excuse me, quick question.
Yes.
So, when you, so the last term, so root of x squared.
Oh, yes.
So, would you have dragged the negative to that or no?
No, no, meaning that if it had been like a minus here in front of
within the parentheses.
Oh no, like the thing is like the formula, the thing is like if you use this version of the formula, the b here refers to the stuff without the negative sign. So it is just like the square root. Like what you could have done, another way to think of this is like, so this is like 5 plus negative root of x squared, right?
So, yeah, that's what I was.
Right, and if you do that, that's totally fine. Like you can see it in that way. But then, like what will happen in this formula is that you end up getting minus root of x squared as the last term in the identity, and that like this negative goes away.
You still have the same thing.
Correct. Yeah. Like, so you end up, there's no way to. Yeah, it will look the same way. But that's actually the. I mean, I don't know if you remember when we went through all these identities. Like the way I found this one in class was to say, oh, you can actually think of these as in this way. That a minus b is a plus minus b, and that's where it comes from. So yeah, there's like definitely it's like a plus regardless of how you see it, if that makes sense. Okay, so like, yeah, there's an x on both terms, so like if you subtract them, they go away, so you get -5 equals 25 minus 10 root of x. And then now it's a little bit just to play with, I'll add 5 and, add 10 root of x to both sides. So I'll do -5 plus 5. Oh, let me do it like quick edge, like big. That's 0 equals 25 with 5 is 30. 30 minus 10 root of x. Okay, and then like what? You add a 10 root of x to both sides. So 10 root of x. Okay, so you get 10 root of x equals 30. 30 is 10 times 3. So like, that means the root of x is 10 over 30 over the 10, which is 3. So root of x equals 3. Okay, and that one is, sorry, yes.
Would it be easy to just like square it then?
Oh yeah, you could, like here, you mean,
Yeah.
you can also square it there, yeah. Once you have it solved for something times square root of x, the important thing is kind of like to have moved the square root to one side of the equation, and then yeah, like you can divide or square it. There's not much of a difference there. I'm just trying to kind of like keep smaller numbers before squaring, because squaring can make the numbers a lot bigger, right? So if you square both sides before dividing, you get 30 squared, which is 900, but that is harder to, like that's easier to screw up, you're kind of like just doing the numbers in your head. So if you can kind of make the numbers as small as possible, that's kind of recommended. But here, once you square both sides, like you kind of see that x has to be 9, right? So just like by square, which is the same that we had found before, right? If you remember. But if this is something you can only see if you kind of put both solutions side by side. If you compare this solution, you'll see that the numbers and the expressions were a little bit friendlier throughout the solution. So the advantage of like kind of having like the square roots or different ends is that you do end up working with like nicer numbers throughout the process. But like regardless of which option you use, right, it is like essentially both like just rely on squaring. So it does give you both will always give you the same results. It's just like how you get there. Yeah, for example, in the last method, like if you do it like the other option, you had to do 15 square at some point. 15 square is 25, but that is easier to screw over, like things like that. Does that make sense? Okay, well, I'll after the quiz, like the prompts, I'll give you kind of like a resource for you to practice. So, because like again, like this is probably the hardest type of equations on the entire course, like something involving two different square roots. Like I think it involves a lot of identities. Like it is easy to mess up like somewhere. But yeah, this is kind of like the example I wanted to do. Like let me stop here. All right, thank you.